y equals 4 minus root x over cubed. Now, what do you notice that's different about this one that we didn't have in the last one?
Chain rule.
Right, good. We're going to need to use the chain rule. Because we have a power and multiple things inside the brackets, we're going to need to do that. So, oh, actually, first of all, I should tell you what we're actually trying to do here. The first thing, I am being told that there is a point P, which is at 4, 8. There is a point Q, which is at 9, 1, and they intersect at R. So I want to know R. So find R. So what I really want to do is find when these two things equal each other, right? So we know this from our linear algebra. When two equations equal each other, that's the point of intersection. So these two are, they both intersect with this. So this is the equation. Oh, you know what? Sorry, I didn't give you enough information here. The normal at this point and the normal at that point intersect at R. Sorry, I forgot to use this word. So the normal of this at point P and the normal of this at point Q intersect at point R. So the first thing we're going to do is get our derivatives at these points. All right, so we want to know our gradients at these points, which means we need to derive. So let's do P first. So I've got, what am I going to do? dy dx is 3, 4 minus root x squared. Okay, so what I'm going to do is I'm actually going to rewrite this a little bit differently. This is that, right? So I'm just going to rewrite this I might just rewrite it here to make our lives, a little bit easier. So this is x to the power of a half instead of root x, just so you can see what's going on a bit easier. All right, so then chain rule says we multiply by this, which Josh, you just said is? Ooh, very careful. Negative half x to the power of? Would you say? Negative half. Okay, that is the derivative of this, right? Bring this power down, multiply it by the negative one, and then subtract one from the power. This looks messy and awful, but it's fine. So what I'm going to do is simplify this a little bit. So this can multiply with this. So I get negative 3 over 2x to the power of negative half times 4 minus x to the power of a half, all squared. This now belongs on the bottom of a fraction, right? So I've got negative 3, 4 minus x. Well, actually, let's just start writing that as a root x. Anyway. All squared over 2 root x, right? This means it's down the bottom, and to the power of a half means a square root, and this 2 here came down here. So this is our derivative. I want to know the derivative. We're dealing with P at the moment, so I need to find it at this point here when x is 4. So I'm going to put 4 into this. So I've got negative 3. So when x equals 4, I've got 4 minus root 4 all squared over 2 root 4. So 3 minus 4 minus 2, which is 2. Well, shouldn't have done that. 2 squared, right? 4 minus 2 is 2. All over 2 times 2, which is 4. So then we have negative 3 times 4, so negative 12 over 4 is negative 3. So that is the gradient at this point. Now we need to do the same thing when x equals 9, because that was point P, and this is going to be point Q. We need the other one as well. So negative 3, 4 minus root 9 all squared over 2 root 9. So negative 3, 4 minus 3 is 1 squared, so just 1. And then we've got 2 times 3, which is 6, which is negative half. So these are the gradients at these points. But if you remember what we were told to find, we were told to find the equation at the normal. We have found the gradient of the tangent. right? So we need to change that first. That's why it's really important to look at the information. Okay, so I'm going to start doing some color coding because I should have done, actually, that's not anything. That's just the whole thing. All right, so let's go down, do some color coding because that'll help. So this is P, and now let's do that. All right, so if we go up here and we deal with P, we've got y minus y1, which is 8, equals m, and we said that the tangent m was -3. So what's this one? What's the normal tangent? Normal gradient? Positive 1/3 x minus x1. So then we have y equals 1/3 x minus 4/3 plus 8. So y equals 1/3 x. Oh gosh, that's annoying. What is that? 8/3 is 24 minus 28ths. So that is a very annoying equation, but that's totally okay. We can live with that. Yeah, all right. And then let's do Q. Whoop, what does what say? Right, this was P. All right, let's do another color. Let's swap to red and we'll do Q. All right, so we said that it was, what was it? I can't remember what it was. -½ So that means y minus y1, the point that we were given is 9,1 over here. Y minus y1 equals m. So what's the m to the normal? Positive 2. X minus x1. This is going to be less terrible, no fractions this time. 2x minus 18 plus 1. So y is 2x minus 17. All right, so those are the two equations that we were asked to find. They are the equations of the normal at those 2 points. The next question, the next part of it, part B, is quite terrible. Part B, there are 2 different ways you can do it. The book uses plane geometry, but I also have a solution which uses trig because we're trying to find a non-right angle triangle, because part B asks, actually, I'm just going to zoom in again. Part B asks us to find the area of triangle PQR. Sorry. Oh, I didn't find R. You're right. I just found 2 equations. What do I have to do to find R? Make them equal each other, right? That's all I'm going to do. So I'm going to say 1/3 x minus 20 over 8 equals 2x minus 17. Now, it's going to make my life a lot easier if I multiply everything here. I'm actually going to do, oh no, it's not, forget it. All right, so then I've got -20 over 8 plus 17 equals 2x minus 1/3 x. So then this gives us 5/3 x. And oh crap, I can't be bothered doing that. What is, I don't think I brought my calculator. Someone do that for me. 17 over 8, I can't be bothered. 29 over what? 2, excellent. All right, so then 29 over 2 divided by 5/3, which means 29 over 2 times 3/5, which is what? 87 over 10, or 8.7. Why am I doing an approximation? Or 8.7. If you're Josiah, you'll definitely write that. If you want me to like you, you'll write this. Okay, so that is the x coordinate. Am I done? No, I need to put it back in here. So y is 2 times x minus 17. I know, these questions can be long, can't they? That's an 87, I know. 160, 174 over 10 minus 17. Oh gosh, who can be bothered? Again, type that in for me. Oh wait, that's 170, it's 4/10, which is 2/5. Okay, that was easier. Okay, so that makes the coordinate 87 over 10 and 2/5. Or if you're Josiah, it'll be 8.7 and 0.4. Well, I mean, he insists on using decimals, doesn't he? Okay, so the next thing, what I'm going to do, because that took ages, what I'm going to do is ask you to open your textbook. Can you have a look at page 203 for me, please? All right, you'll see there that they did a geometric solution. They found the area of the box, right? So it's a rectangle. Then you have three right-angled triangles, and you just subtract the area of those three right-angled triangles. That is a very easy way to solve it. I'm going to show you that there is another way to do it using trig, but their way is so much easier than what I'm about to show you. It's a lot less work. So my answer also gets exactly the same result, which kind of means that it doesn't matter which way you do it, right? There are often multiple ways to do this. Why am I unable to